On December 14th, as they prepared to climb back into the lunar module, Gene Cernan looked out across the valley.
Before taking his last breath, a veteran NASA engineer broke his silence and admitted something absolutely incredible about their missions beyond the moon. His confession left everyone wondering what else might be hidden up there. Why did NASA hide this discovery from the world for so long? Join us as we explore the mind-blowing revelation that changed everything we thought we knew about space exploration. Apollo 12, lightning strike and moon ring. 4 months after Neil Armstrong took his famous first step, another massive Saturn V rocket sat ready on the launch pad in Florida, waiting to blast off into space. This time, the mission was called Apollo 12, and it launched on November 14th in 1969. But the crowd watching was much smaller than before, even though President Nixon himself stood among them to witness the historic moment. Then something unexpected happened as dark clouds gathered overhead and rain started pouring down heavily. Suddenly, bright lightning bolts cracked through the sky and struck the enormous rocket not just once, but twice in quick succession, causing warning lights to flash frantically all over the cockpit instruments. The astronauts inside felt their hearts racing as they watched their control panels go completely haywire with confusing signals flashing everywhere. And Commander Pete Conrad came incredibly close to hitting the abort button, which would have canceled the entire mission right there on the spot. Just when everything seemed lost, a voice crackled over the radio from Mission Control, saying something that sounded like complete nonsense to most people in the room. The mysterious instruction was to try switching something called SCE to auxiliary mode, which meant absolutely nothing to the panicking crew at first. However, astronaut Alan Bean suddenly recognized what those words meant, because SCE stood for Signal Conditioning Equipment, which was basically the electronic box that translated all the raw electrical information from the spacecraft into readable data that the crew could actually understand and use. The powerful lightning strikes had scrambled this crucial system and turned their instrument panels into meaningless gibberish. But flipping the switch to auxiliary mode forced the box to draw power from backup sources instead, which was basically like hitting a reset button on a frozen computer. Within just a few seconds, the instruments blinked back to life and started showing correct information again, allowing the mission to continue successfully. Apollo 12 had a really special goal that was different from Apollo 11 because this mission wasn't about being first or becoming famous. Instead, NASA wanted to prove they could land exactly where they planned to land, rather than just anywhere on the moon's surface, which required incredible precision and skill. 3 days after launching from Earth, the lunar module descended with surgical accuracy toward its target, and the astronauts touched down only 180 meters away from an old robotic probe called Surveyor 3 that had been sitting alone on the moon for over 2 years collecting dust. Conrad and Bean walked carefully across the gray, dusty surface to reach the old machine. Then they used special tools to unbolt several pieces from it and brought those parts back home to Earth for scientists to study. When researchers examined these components in their laboratories, this gave NASA proof for the first time that hardware and possibly even microscopic organisms might be able to endure long-term survival in the brutal conditions of outer space. Survival against all odds. After Apollo 12 proved that NASA could land precisely where they wanted, the space agency felt confident about continuing their lunar exploration program with even more ambitious missions planned. On April 11th in 1970, the Apollo 13 spacecraft lifted off from Florida and headed toward a lunar region called the Fra Mauro Highlands, which scientists believed contained some of the oldest and most interesting rocks on the moon's surface. The 3 astronauts on board were Jim Lovell, who commanded the mission, Jack Swigert, who piloted the main spacecraft, and Fred Hayes, who would have piloted the lunar lander. And all of them expected another smooth and routine flight to the moon, just like the previous missions. For the first 2 days of their journey through the vast emptiness of space, that's exactly what they experienced, as everything worked perfectly according to plan. Then, when the spacecraft was more than 300,000 kilometers away from Earth, which is an unimaginably huge distance where no rescue was possible, one of the oxygen tanks suddenly exploded without any warning. In a single terrifying moment, the planned moon landing was immediately canceled, and simple survival itself became the only mission that mattered anymore. The only lifeboat available was the tiny lunar module called Aquarius, which had been built and designed for just 2 men to spend a couple of days on the moon's surface, not to keep 3 grown men alive for days in the freezing vacuum of deep space. The cabin temperature inside fell close to freezing point and made the astronauts shiver constantly. while condensation from their breath coated the cold metal walls with moisture, and the limited food supplies became almost inedible. Fred Hayes developed painful chills and a serious kidney infection that could have killed him. But perhaps the worst problem of all was that carbon dioxide from their exhaled breath built up to dangerously poisonous levels inside the cramped spacecraft. To make this desperate situation even worse, the square-shaped air filters from the command module didn't fit into the round ports of the lunar module at all. NASA engineers on the ground quickly guided the freezing and exhausted crew through an improvised solution using whatever materials they could find on board, including duct tape, plastic bags, and pieces of cardboard, creating a makeshift filter that pulled the poisonous carbon dioxide from the air and literally saved their lives. They used old-fashioned slide rules by shouting through crackling radio signals, and even the return trajectory had to be adjusted by firing the lunar module's small engine while the astronauts steered by sight alone, carefully lining up Earth and the Sun through their tiny window, because their navigation instruments were dead. After 6 absolutely harrowing days of constant danger and problem-solving, Apollo 13 finally splashed down safely in the Pacific Ocean. Redemption in the Highlands. The failure of Apollo 13 to reach the moon's surface had shaken public confidence in the space program badly, so the next flight carried the incredibly heavy weight of redemption on its shoulders, because NASA desperately needed to prove that lunar exploration could continue safely. On January 31st, in 1971, Apollo 14 lifted off from the Kennedy Space Center and headed once again toward the Fra Mauro Highlands, the same target that Apollo 13 had been forced to abandon during their life-threatening emergency. Commander Alan Shepard was now getting his chance to walk on the moon, after being the very first American to travel into space almost a decade earlier, which made this mission especially meaningful for him personally. However, even before the crew could reach the lunar surface, another potential disaster struck without warning and threatened to end the mission prematurely. When the command module tried to dock with the lunar lander in space, which was an absolutely essential procedure that had to work perfectly, the two spacecraft stubbornly refused to lock together properly, no matter what the astronauts tried. Without achieving that secure seal between the two vehicles, Shepard and lunar module pilot Edgar Mitchell could never descend to the surface because they wouldn't be able to transfer between the spacecraft safely. Mission controllers back on Earth scrambled desperately for hours, trying every possible command and procedure they could think of to solve the mysterious problem. Finally, after many tense hours, Shepard decided to switch to manual control and take matters into his own hands. Then he carefully rammed the two ships together with just enough force to make the stubborn latch click into place and lock securely. Against tremendous odds and technical difficulties, Apollo 14 was miraculously back on track to complete its mission. On February 5th, Shepard and Mitchell stepped carefully onto the ancient highlands that had seemed almost cursed just 1 year before when Apollo 13 had failed. Their primary goal was geological research, because they wanted to sample something called the Fra Mauro Formation, which scientists believed held crucial clues about the moon's extremely violent early history, billions of years ago. Over the course of 2 separate moonwalks, the astronauts hiked across the rolling terrain while hauling their tools and equipment in a handcart specially designed for the lunar environment. The rock samples they carefully collected and brought back to Earth completely changed the entire story of lunar geology in ways nobody had expected. When scientists analyzed these rocks in their laboratories, they discovered the samples were actually impact breccias, which meant they were shattered fragments of older rocks that had been violently welded together by enormous asteroid and comet collisions that happened billions of years ago. These fascinating samples proved that the bright lunar highlands were shaped primarily by catastrophic impacts from space rather than by volcanic eruptions, as scientists had once believed. And this insight reached far beyond just understanding the moon, because it meant Earth had also endured a similar violent bombardment during its youth, which made researchers completely rethink how planets form and evolve. The Genesis rock and moving science. The missions were now evolving from simple landings into genuine scientific expeditions, and the next attempt would completely redefine the very purpose of lunar exploration for everyone involved. On July 26th, in 1971, Apollo 15 lifted off, carrying a longer, heavier, and far more ambitious mission than any previous flight to the moon. This was the first of what NASA called the J missions, which were dramatically different from the short, occasional visits that earlier astronauts had made to the lunar surface. This particular time, the astronauts would stay on the moon for nearly 3 full days, giving them much more time to explore and conduct careful scientific research. Commanded by David Scott with James Irwin as the lunar module pilot, Apollo 15 landed near a breathtaking region called Hadley Apennine, which featured towering mountains and mysterious winding channels carved deep into the ancient surface. For the very first time in human history, a battery-powered lunar rover vehicle rolled down the ramp of the landing module, which allowed the astronauts to travel many kilometers away from their spacecraft, rather than being limited to short walks. What had once been just a few hundred meters of cautious exploration suddenly became wide-ranging traverses into deep craters, up steep slopes, and across the ancient landscape that had remained untouched for billions of years. The most celebrated scientific find of the entire mission came not from a long rover drive, but from a single remarkable piece of rock that would become world-famous. Scott and Irwin carefully picked up a pale, crystalline sample that scientists back on Earth would later affectionately call the Genesis Rock, which was an incredibly appropriate name, dating back an astonishing 4.1 billion years. This ancient specimen was an anorthosite that had formed from the moon's primordial crust during the time when a global ocean of molten magma slowly solidified and cooled. Holding this rock in their gloved hands was literally like holding a precious fragment of the earliest history of our entire solar system. Apollo 15 also expanded scientific research in many subtler but equally important ways that don't get as much attention. The instruments from the advanced ALSEP package continuously monitored seismic waves traveling through the moon's interior, measured heat flow coming from deep below the surface, and detected charged particles streaming constantly from the sun. Working together, these sophisticated instruments transformed the moon from being just a distant curiosity in the night sky into a planetary body that could be studied in tremendous depth and detail. As an interesting side demonstration, Commander Scott confirmed the famous law that Galileo had proposed centuries earlier by conducting a simple but elegant experiment. He dropped a heavy geology hammer and a light feather side by side on the airless surface, beautifully showing that in a vacuum without any air resistance, both objects would hit the ground at exactly the same time, regardless of their different weights, which would be impossible to demonstrate on Earth. Chemical twins and ancient impacts. The Apollo program was now pushing deeper into understanding the moon's secrets, and the next mission would go even further by revealing something absolutely crucial about Earth itself and how our planet formed billions of years ago. On April 16th in 1972, Apollo 16 launched toward a rugged plateau called the Descartes Highlands, which had been carefully chosen by mission planners because scientists believed it might hold some of the oldest and most pristine lunar crust anywhere on the moon's surface. Commander John Young and Charles Duke would land on this ancient terrain and explore it thoroughly, while their colleague Ken Mattingly orbited high above in the command module, keeping watch over them. Interestingly enough, Mattingly had actually been chosen to fly on the disastrous Apollo 13 mission 2 years earlier, but he had contracted measles just before launch and was replaced at the very last moment by Jack Swigert, which probably saved him from that terrifying near-death experience in space. A serious problem developed in the lunar module's steering system that threatened to scrub the landing entirely and send everyone home without accomplishing anything. Because if this critical system failed during the descent, or more importantly during the ascent back to orbit, the astronauts might never be able to lift off from the surface again. Mission controllers at NASA headquarters debated intensely for many stressful hours, carefully weighing the risks to crew safety against the tremendous scientific value of continuing the mission. Finally, after seeing no signs of the problem getting worse, NASA officials gave a cautious go-ahead decision, and Young and Duke descended in their spacecraft, settling gently onto the Descartes plain. Once safely on the surface, the two astronauts drove their rover across ridges and into craters, methodically collecting samples from some of the most ancient terrain that any human being had ever visited in history. Back on Earth, after the mission ended, detailed chemical analysis of those precious rocks eventually led to an absolutely stunning revelation in the field of planetary science that changed everything. The Moon and Earth are essentially chemical twins, almost identical in their basic composition despite being two separate worlds. Apollo 16 samples, just like those collected from earlier missions, showed oxygen isotopes and trace elements that were nearly identical to those found in Earth's mantle, which was completely unexpected and demanded an explanation. This uncanny chemical match strongly reinforced a bold new theory that had been taking shape in scientific circles during the 1970s, though it seemed almost too bizarre to be true at first. According to this revolutionary idea, billions of years ago, when the solar system was still young and chaotic, a massive planet-sized body, later named Theia, that was roughly the size of Mars, slammed violently into the early Earth in a catastrophic collision. This unimaginably powerful impact blasted enormous amounts of molten debris from both bodies into orbit around Earth, and this superhot material eventually cooled and coalesced together over time to form the moon we see today. The evidence supporting this frankly bizarre idea was written clearly all over the Apollo samples, showing a moon with Earth's exact chemical fingerprint, but mysteriously stripped of volatile materials and iron, which is exactly what scientists would expect from a world that was literally born in fire and violence. The astronauts themselves noticed small details during their exploration that made the moon feel simultaneously alien yet strangely familiar at the same time. Orange soil and the final footprints. By 1972, the Apollo program was rapidly winding down, as government budgets were shrinking dramatically, and public interest in moon landings had sadly faded away, which meant Apollo 17 would be the very last chance for NASA to leave a lasting scientific mark on lunar exploration. This final mission would push science to its absolute limit and make the most of humanity's last visit to another world. On December 7th in 1972, the final Saturn V rocket thundered off the launch pad at night in a spectacular display of fire and light, making it the only Apollo mission that lifted off after sunset rather than during daylight hours. The massive rocket carried Commander Gene Cernan, pilot Ron Evans, and for the first time in the entire history of space exploration, a professionally trained scientist named Harrison Schmitt, who was an expert geologist. Their ambitious goal was crystal clear from the beginning, which was to make absolutely the most of humanity's last visit to the moon by conducting the best science possible. Apollo 17 targeted a dramatic location called the Taurus-Littrow Valley, a site that had been carefully chosen by mission planners for its fascinating mix of dark volcanic plains and bright mountain slopes that suggested a complex geological history. For 3 full days, Cernan and Schmitt lived and worked on the desolate surface, and they spent a record-breaking 75 hours outside their landing module exploring the alien landscape. The 2 astronauts drove more than 30 kilometers in their lunar rover and worked tirelessly to haul back the heaviest load of lunar samples ever collected, which totaled an impressive 110 kilograms of carefully selected rocks and soil. Every single stop along their traverses was meticulously planned, like a geological field trip on Earth, with Schmidt's professionally trained eye catching important details that no astronaut before him could have possibly noticed or understood. Then came the discovery that would make Apollo 17 absolutely legendary in the history of lunar science and capture imaginations around the world. While carefully sampling soil near a crater, Schmitt suddenly spotted something extremely strange, mixed into the normal gray dust that covered everything. It was bright orange soil that seemed completely out of place, and under his visor lamp, it glittered mysteriously like tiny glowing embers scattered across the surface. Back on Earth after the mission, scientists analyzed this strange material in their laboratories and realized with excitement that it was actually volcanic glass beads that had formed an astonishing 3.6 billion years ago during gargantuan eruptions when superhot lava sprayed from deep inside the moon's interior like a spectacular fountain of sparks. This discovery was definitive proof that the moon's volcanic history was far more complex and much more violent than anyone had previously imagined, especially after finding all those impact rocks on earlier missions that had suggested volcanism was relatively minor. The mission also deployed an expanded suite of sophisticated experiments, including improved seismic studies and heat flow probes, which together painted the most detailed picture yet of the moon's internal structure and its long history. Every single rock bag and every carefully extracted core sample added another crucial piece to the enormous puzzle of how the moon, and by extension Earth itself, had evolved since the very dawn of the solar system billions of years ago. On December 14th, as they prepared to climb back into the lunar module for the last time, Gene Cernan paused and looked out across the beautiful valley one final time, knowing that his footprints and Schmidt's would remain the last marks left by humans on the moon for over half a century. Ongoing scientific debates, mysteries still unsolved. Even though the Apollo program ended decades ago, and brought back hundreds of kilograms of precious moon rocks for scientists to study in laboratories around the world. Researchers are still actively debating many fundamental questions about our closest neighbor in space and its mysterious origins. The truth is that, despite all the incredible discoveries made during those 6 successful lunar landings, the moon continues to guard some of its deepest secrets and refuses to give up all its answers easily. To this very day, scientists continue to debate the exact timeline of the moon's long and complex history, arguing passionately about when certain crucial events happened and in what order they occurred over billions of years. The rock samples brought back by brave astronauts have provided enormous amounts of valuable information, but they sometimes present a confusing and even contradictory picture that doesn't always fit together neatly like pieces of a puzzle should. Different rocks seem to tell slightly different stories about the same events, which makes creating a single coherent narrative of lunar history surprisingly difficult, even with all our modern technology and analytical methods. Even the giant impact hypothesis itself, which has been the dominant theory explaining the moon's formation for several decades now, is currently being seriously doubted and questioned by some researchers in the scientific community. This famous theory proposes that a massive Mars-sized body called Theia crashed violently into the early Earth roughly 4.5 billion years ago, and that the moon formed from the superhot debris that was blasted into orbit around our planet by this catastrophic collision. For many years, this idea seemed to explain most of the evidence quite well, including why the moon and Earth have such similar chemical compositions, and why the moon lacks a large iron core like Earth has. However, as scientists have conducted more and more detailed chemical analyses using increasingly sophisticated instruments and techniques, they have discovered some puzzling differences between Earth and moon rocks that the simple giant impact theory struggles to explain convincingly. For example, some elements and isotopes show slight variations that shouldn't exist if the moon really formed entirely from material that came from Earth's mantle during a collision. These small but significant differences have led some researchers to propose alternative theories or modifications to the original impact hypothesis, such as the idea that multiple smaller impacts, rather than one giant collision, might have created the moon over a longer period of time. Other scientists have suggested that perhaps the impacting body called Theia had a chemical composition that was almost identical to Earth's by pure coincidence, which would explain the overall similarity, while still allowing for the small differences we observe today. Some researchers have even proposed more exotic scenarios, involving the early Earth spinning much faster than we previously thought, or the moon forming much closer to Earth than current models suggest. Each of these alternative ideas has its own strengths and weaknesses, and the scientific community remains divided about which explanation fits all the available evidence best. The volcanic history of the moon also continues to generate heated debates among planetary scientists who study the Apollo samples and data. While the orange glass beads discovered during Apollo 17 proved that explosive volcanism definitely occurred on the moon billions of years ago, scientists still argue about how widespread this volcanic activity really was, how long it lasted, and what caused it to eventually stop completely. Some researchers believe the moon had a much more active volcanic past than the relatively quiet picture suggested by current theories, while others think the volcanic evidence we have found represents only brief and isolated episodes of activity. In some parallel universe, where Apollo 11 was the only lunar mission that ever happened, and NASA never went back to collect more samples, we would have almost nothing to learn about or debate regarding the moon's complex history. The proof in the latter. For those people who still stubbornly doubt the authenticity of the historic moon landings, despite all the overwhelming evidence that exists, including photographs, rock samples, and testimony from thousands of NASA employees and independent observers around the world, something interesting suddenly occurred while working on researching all these Apollo missions and their incredible scientific achievements. A new and compelling counterpoint emerged that conspiracy theorists have apparently never seriously considered or thought through completely. You see, the later Apollo missions from 12 through 17 actually provide the absolute best proof that none of it could ever have possibly been faked or staged in some secret Hollywood studio. And the reasoning behind this conclusion becomes obvious once you think about it carefully and logically. If you really wanted to stage just one mission, to fake going to the moon and trick the entire world into believing American astronauts had landed there, then sure, maybe you could theoretically keep that enormous secret among a small group of conspirators who were all sworn to silence. But then the obvious question becomes, why would you possibly risk repeating the incredibly dangerous act 5 more times and multiplying your chances of getting caught exponentially with each additional fake mission. Why would NASA distribute hundreds of kilograms of supposedly fake moon rocks to geologists and planetary scientists working at universities and research institutions across the entire world if those rocks weren't actually from the moon at all? Because surely someone somewhere would eventually test them and discover they were just Earth rocks or meteorites. Why would you create thousands of pages of detailed scientific data and measurements that all had to be internally consistent and match up perfectly with each other, when a single mistake or contradiction could expose the entire fraud immediately? Why would you involve thousands and thousands of engineers, technicians, scientists, astronauts, and support staff in an elaborate deception when every single person represented another potential whistleblower who could reveal the truth at any moment? It was exactly those later missions after Apollo 11 that delivered such an enormous amount of detailed scientific data that no hoaxer in their right mind would ever dare to invent from scratch, because creating that much realistic and internally consistent fake information would actually be harder than just going to the moon for real. Each piece of data brought back by the Apollo astronauts has been carefully cross-checked against other pieces, published in peer-reviewed scientific journals where experts could scrutinize every detail, and analyzed independently by researchers working in different countries who had no connection to NASA or the American government whatsoever. The rock samples themselves have been studied using techniques that didn't even exist when the Apollo missions were flying, and every single new test has confirmed that these rocks really did come from the moon and couldn't possibly have formed anywhere on Earth. The seismic data collected by instruments left on the lunar surface operated continuously for years after the astronauts left, sending back information that revealed the moon's internal structure in ways that would be impossible to fake. The laser reflectors placed on the moon during several missions are still being used today by scientists who bounce laser beams off them to measure the exact distance to the moon with incredible precision, and anyone with the right equipment can verify this for themselves. This way, NASA was able not just to see the moon in all its glory and conduct groundbreaking scientific research, but the space agency also showed the entire world in absolutely no uncertain terms that the most complex human space flights ever attempted were indeed very, very real, and not some elaborate Cold War propaganda stunt. Apollo 11 may have given us that famous first step that everyone remembers and celebrates, but it was really the whole ladder of missions from Apollo 12 through 17 that made the achievement itself completely undeniable and provided irrefutable proof that humans really walked on another world. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.